First law of your thermodynamics. Anyone? Based on law of conservation of energy, delta Q is equals to delta U plus of your delta W. Q is equals to your U plus of your delta W. Delta Q is nothing but what, beta? Heat. Delta U is what for me? Internal energy. Internal energy. Internal energy का formula क्या है बेटा? Delta U is always equals to N into CV into delta T. By default, you need to remember the internal energy formula. Okay. Then W is right now for me work done. W is your work done. Work done is given by the formula W is equals to your P into your delta V, or that is equals to your NR into your delta T. Clear? So first law of thermodynamics is based upon your law of conservation of your energy. Delta Q is equals to delta U plus of your delta W. क्लियर? चलो साइन कन्वेंशन बताइए इसका. साइन कन्वेंशन. I'm talking about delta Q. Okay. Delta Q can be positive and delta Q can be negative. It all depends upon what? How you are giving the heat. Like say delta Q is positive if heat is given to system. If heat is given to the system, we take delta Q is equals to positive. Now, when we take the delta Q to be negative, if heat is taken out, if heat is taken out from the system, then we will take delta Q is equals to your negative. Am I clear? Then internal energy, delta U. Delta U is also positive or negative. Delta Q can be positive and delta Q can be your negative. Delta U depends upon what, beta? Anyone? Delta U depends upon what? Temperature. That means if temperature increases, then we take positive. If temperature decreases, then we take delta U is equals to negative. Clear? In the same way, work done. W will be equal to W can also be your positive and work done can also be your negative. Work done will depend upon volume, beta. It depends upon what? Volume. So can I say that when work is done by the system, it will be your positive. When work is done by the system, that means when volume increases, directly can say when volume increases, work done will be positive. In the same way, when work is done on the system, that means when volume decreases, then work done can be taken as of your negative. Am I clear? Once again, delta Q is equals to delta U plus delta W. Delta Q is nothing but heat, delta U is internal energy, and W is work done. Then delta Q can be positive or negative. It is positive when heat is given to the system, and delta Q is negative when heat is taken out from the system. Internal energy is positive when temperature increases, and internal energy is negative, temperature is decreasing, because internal energy will depend upon the change in temperature. Work done is positive when work is done by the system. When work is done by the system, it will be positive. When work is done on the system, then it will be your negative. That means when volume increases or decreases, like say volume increases positive, volume decreases negative. Am I clear?
Yes. Yeah, sure.
Next one. Internal energy. Represented by delta U. Okay. So from the first law of thermodynamics, delta Q is equals to delta U plus delta W. This is known as what? Float. First law of thermodynamics. Delta U will be equal to delta U is equals to your N into F by 2 into R into delta T. You can write like this. Or else I can write this one as of your F by 2 into P into delta V. Delta V. Other can be written as of your N into CV into your delta T. These are the different ways we can write the internal energy of your gas. N is nothing but here right now what? Number of moles. Okay. And F is right now for me what? Degrees of freedom. Degrees of freedom. Independent ways in which it possesses the energy. Clear? Very important point. Internal energy delta U is path independent. Theoretical question, but it is independent of path. It depends only on initial and final path. Okay. Delta U is path independent. In the same way, delta U depends upon initial and final states of temperature. Okay, na? It depends upon what? Initial and final states of your temperature. Delta U depends upon your initial and final states, and delta U is independent of your what? Path. And delta U formula, delta U is equals to N into F by 2 R into delta T. R is universal gas constant, delta T is your temperature difference, P is pressure, delta V is change in volume, CV is equals to what beta? Molar specific heat. Molar specific heat at constant volume. Clear? Sure. And one more thing you need to remember better. Work, it is path dependent. It is path dependent function. Internal energy is path independent and work is your path dependent. You need to remember this one better. It is your work is your path dependent function. Am I clear? Sure.
Yes.
Sure. See here beta. Here I am taking your process. Okay. And here I am writing the work done by this one. First one is isobaric process. Isobaric means what beta? Pressure is equals to constant. Next one is isochoric. Isochoric process means volume is equals to constant. Then adiabatic process. Delta Q is equals to 0. Okay. The next one is your isothermal process. In isothermal process, temperature is equals to constant. T is equals to your constant. And last one is polytrophic process. Okay. Sure. Now in this one, tell me what is the work done in isobaric process? Work done is equals to your W is equals to your pressure into your final volume minus of your initial volume. Or else I can write this one as of your NR into your final temperature minus initial temperature. Clear? Next one. In isochoric process, change in volume is 0. So work done in this one will be equal to 0. Next one. Adiabatic process. In the adiabatic process, work done will be equal to, very important beta, nr into delta t divided by 1 minus of your gamma. Okay, or else this will be equal to P into delta V divided by 1 minus of your gamma. Can anyone tell me what is gamma beta? Gamma is equals to Cp divided by Cv. Am I clear? Then an isothermal process, what is the work done? Work done will be equal to your nRT. This is your ln of your V final divided by V initial. Clear? The next one is polytrophic process. This is very important again. Work done will be equal to nr into delta t divided by 1 minus of your x. Or it is right now for me p into delta v divided by 1 minus of your x. Clear? Here it is nRT divided by 1 minus x, or it will be equal to P into delta V divided by 1 minus of your x. Clear beta? These are the formulas which should be committed to your memory. R is your universal gas constant, delta T is your temperature difference, P is your pressure, x is nothing but of your some process, PV to the power of x is equals to constant relations. Okay? So, now see how do you calculate the work done beta? Work done is given by the formula integral of your P into dV. This is your initial volume and this is final volume. Or it is also given as of your area under PV curve. Yes, beta. Work done can be calculated in thermodynamics by using the formula W is equals to integral of your pressure into change in volume, or if graphs are being given, we can take the area under your pressure and volume curve will give me the area under the curve. Like say if it is a circle, area of circle will give me the work done. If it is a triangle, area of triangle will give me the work done. Isn't it? If it is a trapezium, area of the trapezium will give me the work done, like that. Am I clear? Sure. Tell me the answer for this graph beta. There is one graph like this, one more graph like this, and one more graph like this, and one more graph like this, somewhere here. Okay. Now, in this one, I'm taking here right now circle, and here also I'm taking right now the area of circle, and here is right now for me excess pressure, x-axis is volume. If the graph is going like this, and arrow mark is downward direction, okay, and you are going from here, so it is initial volume here is vi, and I'm going to here right now, this is v final, area under this curve. Volume is increasing or decreasing beta? This will give me the work done. That will be positive because volume is increasing. Am I clear? Sure. Now see this graph beta, this is also graph, but on y-axis I'm taking volume and on x-axis I'm taking pressure. I just changed the coordinates. Okay, now here if I'm taking right now, this is one coordinate and here this one is your one coordinate. So this is your initial volume and this is your final volume. Area under this curve will give me the work done. Again arrow mark is in the upward direction, that means volume is increasing. So this will give me the work done. Clear? Am I clear? Both of them are same beta, but here on y-axis we are taking volume, on x-axis we are taking the pressure. Clear? Now see here, this graph, work done by your cyclic process like pressure and volume. Now if I'm moving in the clockwise direction, work done will be equal to how much beta for this one? Work done will be positive. Clear? Now if I'm moving in anti-clockwise direction, if I'm moving in the anti-clockwise direction in your pressure versus volume graph, then work done will be negative. Okay. So now in this one, how do you calculate the work done? Work done will be equal to area enclosed by cyclic curve. That means W is equals to area of circle, isn't it? As it has two different radii, so here the work done will be equal to pi into your R1 square divided by R2 square. That I'll do it later. Just try to remember here. Work done will be equal to work done is equals to area of circle, or work done is equals to area enclosed by the cyclic process. Am I clear? Am I clear? How do you calculate the work done in this one, beta? Work done is equals to your integral of your P into dV, or area under the curve of your P and V. Am I clear? Am I audible?
Yes, sir.
Sure. So I hope you got the two formulas in there, beta. First one in the thermodynamics you need to remember is first law of thermodynamics, delta Q is equals to delta U plus delta W. Then internal energy formula, delta U is equals to your N into Cv into delta T, or it is F by 2 into Nr into delta T, or P into delta V. Then work done in the different processes, in isobaric process, in isochoric process, in adiabatic process, in isothermal process, and in the polytrophic process. And how do you calculate the work done? Means work done is equals to area under the curve or integral of your P into dV. Sure. Next one is molar specific heat. Molar specific heat of process, represented by letter C. So what do you mean by molar specific heat, beta? It is heat required to raise the temperature of 1 mole of substance by 1 degree Celsius. So C of your process will be equal to delta Q divided by N into delta T. This is the molar specific heat formula. So can I write the definition? It is required heat required to raise the temperature of 1 mole of substance, 1 mole of substance by unit degree, by unit degree. This is the definition. Clear? Now tell me, for isobaric process I'm going to write. First process I'm taking isobaric process. For isobaric process, what is the molar specific heat? Isobaric process, beta, apply the first law of thermodynamics. Delta Q is equals to delta U plus of your work done. From first law of thermodynamics, float. Delta Q will be equal to F by 2 Nr into delta T, and work done will be equal to Nr into delta T. Okay, that means delta Q will be equal to Nr into delta T will be common. This will be your F by 2 plus of your 1. I need the C of process. That means molar specific heat at your constant pressure Cp will be equal to delta Q divided by N into your delta T. So delta Q value is how much, beta? Nr into delta T into F by 2 plus 1 divided by N into your delta T. Delta T, N and N will get cancelled. So what is the Cp of the process, beta? Molar specific heat for isobaric process will be equal to F by 2 plus 1 into R. This is the molar specific heat at your constant pressure. Constant pressure means what type of a process? Isobaric process. Am I clear? Am I clear?
Yes,
If I
sir.
say, for example, if gas is, if I say that if gas is monoatomic, for monoatomic, what is the number of degrees of freedom, beta? F is equals to 3. So for F is equals to 3, C of the process will become how much for me, beta? 3 by 2 plus 1 into R. So that will be equal to how much for me, beta? 5 by 2 into R. Am I clear?
Yes,
Isn't it?
sir.
In the same way, if gas is diatomic, For diatomic, number of degrees of freedom are 5. So for this one, molar specific heat at constant pressure is equals to 5 by 2 plus 1 into R. So this value will be equal to how much better? 7 by 2 into your R. Am I clear? C of your process, you got an idea for your isobaric process. So what is a molar specific heat beta? Molar specific heat is nothing but heat required to raise the temperature of heat required to raise the temperature of 1 mole of substance by 1 unit degree. So C of the process is how much for me? C of process is delta Q divided by N into delta T. N is number of moles. Then from the first law of thermodynamics, delta Q is equal to delta U plus delta W. From simplifying it, we are getting delta Q will be equal to how much beta? Delta Q will be equal to your this one. Nr into delta T F by 2. Now take the process formula. Cp is equals to your delta Q divided by N into delta T. So if I simplify it, we are getting Cp is equals to F by 2 plus 1 into R. That is the formula which you need to remember. Am I clear? Am I clear? Sure. Next process. What is the next process? Isochoric process. What do you mean by isochoric process, beta? Constant volume, Cv. Again from first law of thermodynamics. From first law of thermodynamics, delta Q is equals to delta U plus work done. Work done will be equal to how much in this process? 0. That means delta Q will be equal to delta U. That means delta Q will be equal to, this value will be equal to how much for me? F by 2 and into R into delta T. This is your delta Q. Am I clear? Now tell me what is the C? Cv will be equal to delta Q divided by N into delta T. This is our formula. Delta Q is equals to F by 2 and R into delta T divided by N into delta T. Delta T, N and N will get cancelled. C of the given process at constant volume will be equal to how much for me? F by 2 into your R. This is the molar specific heat at your constant volume. Am I clear? Any doubt in this one to anyone? Cv is equals to F by 2 into your R. Clear? And what is delta Q? Delta Q for isochoric processes F by 2 Nr into your delta T. Now tell me for monatomic gas.
3 by 2R.
Monatomic gas. For monatomic gas, number of degrees of freedom are 3. So Cv will be equal to how much beta? 3R divided by 2. Very good. Now tell me for diatomic gas beta.
5 by 2R.
Diatomic gas. Very good. For diatomic gas, F value will be equal to your 5. So Cv will be equal to how much for me? 5 by 2 into your R. Any doubt in this formula? So these are the formulas which should be remembered at the tip of your hands beta. Clear? Chalo. Next process. Isothermal. Isothermal process. What do you mean by isothermal process? Temperature will be constant. That means delta T will be equal to 0. Am I clear? From first law of thermodynamics, float. From first law of thermodynamics, delta Q is equals to delta U plus work done. Okay. If delta T is 0, internal energy will become 0. That means delta Q will be equal to work done. Am I clear? Am I clear? So, molar specific heat at constant temperature will be equal to delta Q divided by N into delta T. That is equals to delta Q divided by N into delta T is 0. 1 by 0 will be equal to how much for me? Infinity. Molar specific heat for your isothermal process is equals to infinity. Theoretical question. Done? Any doubt in this one? Molar specific heat for isothermal process, what is the value? Infinity. And delta Q will be equal to how much for me? Work done. Am I clear?
Yes, sir.
Sure. Next one. Adiabatic process. Adiabatic process. Okay. Adiabatic process. In adiabatic process, what is zero beta? Anyone?
Delta Q.
Yeah. So molar specific heat for your adiabatic process is equals to delta Q divided by N into delta T. Delta Q is 0, so it is 0 divided by N into delta T. So molar specific heat for your adiabatic process will be equal to 0. Am I clear? But don't leave your classes, beta. If I can't every time admit you, if from next time if you are leaving, I can't allow you into the class. Today is the first section for the new students. I'm telling you, if you are in the class, you please be in the class till the session completes. Because every time I can't go and add for you every time there. Okay. So molar specific heat for adiabatic process also we got. So C for adiabatic process is how much for me? 0. Now what is the process left out? Now we got for all the processes now beta. Sure. The next one is very important. Molar specific heat. Molar specific heat capacity for polytrophic process. For polytrophic process. Okay. What is a polytrophic process beta? PV to the power of x. PV to the power of x is equals to constant. Okay. Then delta Q is equals to delta U plus of your work done from first law of thermodynamics. I can write delta Q is equals to, this is F by 2 NR into delta T plus work done will be NR into delta T. For polytrophic process it is how much? 1 minus X. This is your delta Q. If I know the delta Q, can I calculate the C for the polytrophic process beta? C for your polytrophic process will be equal to delta Q divided by N into delta T. That will be equal to this one here, NR into delta T will be common into this one is F by 2 plus 1 by 1 minus X divided by N into delta T. N gets cancelled, delta T will get cancelled. So C for your polytrophic process will be equal to, this is your R into your F by 2. This one is your F by 2 plus 1 by 1 minus x. So this is the standard formula for your molar specific heat for your polytrophic process. Am I clear? The formulas, this all formula should be on your tip of your fingers better for doing the numericals. Done? Sure. I'm giving one example better. See how can you do this question. For a monatomic gas, number of moles N is equals to 2. Okay. Monatomic gas goes from 300 Kelvin to your 500 Kelvin. Okay. And the process given is PV to the power of minus 7 by 2 is equals to constant. Okay. Question is find number 1 work done. Okay. Number 2 delta Q. Number 3 delta U. Delta fourth one molar specific heat for the given process. Okay. This is a question. Read the question carefully. Monatomic gas number of moles is given how much for me? 1. Compare with the polytrophic process beta. Compare PV to the power of minus 7 by 2 is equals to constant with PV to the power of x is equals to constant, where x value is equals to how much beta? Minus 7 by 2. So value of x is equals to minus of 7 by 2. What the first question is asking? Work done. Work done means W. Work done W. So work done formula is how much beta? Work done W for polytrophic process is equals to nr into delta T divided by 1 minus x. So that is equals to number of moles is how much for me? 2 into this one is R. Delta T is final temperature minus initial temperature. Final temperature is 500. Initial temperature is 300 divided by 1 minus of 7 by 2. Okay. Now simplify this one. So work done W is equals to this one is 2R. 500 minus 300, this will be equal to 200 divided by 1 plus 7 by 2. So that will be equal to 400 into R divided by, this value will be equal to how much beta? 9 by 2. So this will be equal to 4 to the 8. This will be equal to your 800 into R divided by 9. So work done will be equal to, so if I am dating the formula, work done for this given question is coming for me as, answer is W is equals to 800 into R divided by 9. This is your answer. Am I clear? I have taken 4 questions, but he will be asking in exam any one question. Now tell me, how do you calculate the internal energy for the polytrophic process? Delta U will be equal to your, how do you calculate delta U, internal energy? Use first law of thermodynamics. Delta Q is equals to delta U plus of your work done. Okay. Second question, delta Q is asking. So delta U will be equal to how much beta? F by 2 nr into delta T plus work done. Work done is how much right now we got? 800 into R divided by 9. Just now we got above. What type of gas it is? Monatomic. So for monatomic, number of degrees of freedom 3. 3 by 2, number of moles 2 into R into temperature 500 minus of your 300 plus 800 into R divided by 9. This 2 will get cancelled. So this value is coming out for me how much beta? So this one is 3 into R into this one is 200 plus 800 into R divided by 9. So 3 to the 6, that is 600 into R plus 800 into R divided by 9. Okay, so if I take the simplification, delta Q will be equal to 6200 divided by 9R. You can still simplify depending upon your options. You can just take care of your calculations. Am I clear with this one? So delta Q got the second one. So this one is delta Q. Okay, can anyone tell me internal energy beta? Third question, what is asking is internal energy. Internal energy formula F by 2 NR into delta T. So number of degrees of freedom 3 divided by 2. Monatomic gas, na? Number of degrees of freedom are 3 by 2. Number of moles are 2 into R. Temperature is 500 minus 300. That is given in the problem. This 2 will get cancelled. So this will be equal to 3R into 200. So the answer will be equal to 600 into R is your internal energy. Am I clear? Sure.
Yes, sir.
What is the fourth question is asking? See the question. C of process. For the polytrophic, how do you calculate the C of process beta? C of your process actual formula is delta Q divided by N into delta T. Okay. Now delta Q is known for me beta. I'm writing this one, or else you can directly use the standard formula also. Delta Q value I know. It is 6200 into R divided by 9 divided by number of moles is 2. Temperature difference is 500 minus 300. Okay na? So this will be equal to 6200 into R divided by 9 into 2 into your 200. This 20, this 2 zeros will get cancelled. Okay. So how much I'm getting this one, you see, but this 2 ones are 2 threes are 2 ones. Am I clear? So C of your process will be equal to 31 into R divided by 9 twos are 18. So this will be the C of your process. Got an idea how we get the questions on this one? On the polytrophic process? There is any doubt, you let me know. The given process in the problem is what? PV to the power of minus 7 by 2. Gas is monoatomic. So for monoatomic, number of degrees of freedom is how much beta? 3. Diatomic is how much? 5. You need to commit it to the memory beta. Monoatomic gas, number of moles N is equals to 2 gas, goes from 300 Kelvin to 500 Kelvin. Okay. Final temperature is 500. Initial temperature is 300. And the process given is PV to the power of minus 7 by 2 is equals to constant. He is asking 4 questions in this one. Work done, internal energy, delta Q and C of your process. What I did is, I compared the given process PV to the power of minus 7 by 2 with PV to the power of x is equals to constant. So we are getting the value of your x is equals to how much for me? Minus of your 7 by 2. Am I clear? Then use the work done formula in delta Q formula, then delta U formula and C of your process. Done beta? Any doubt? అసలు అర్థమవుతుందా? Am I going speed?
No, sir.
Alvina,
Yes,
समझ में आ रहा?
sir.
हर्षिता,
हाँ सर समझ आ रहा అర్థమైంది
चलो वो क्वेश्चन చేస్తారా మీరు? Will you do one question beta? So
yes
take
sir
a rough paper, everyone take a rough paper soon. I'll write the question, you try to do it on your own. चलो, the question is something like this. Monoatomic gas, again number of moles is equals to 4, undergoes a process T square is equals to constant. Okay, and its temperature varies, and its temperature varies from 200 Kelvin to 400 Kelvin. Okay, find number 1 work done, number 2 delta U, number 3 delta Q, and fourth one C of your process. Now see, there is a slight difference between previous questions and this question better. Can anyone tell me what is that difference? Can anyone tell me what is the difference? Previously, the process is in the form of P and V,
Constant.
but now the process is not in the form of P and V, but it is T and P. Okay. So we need to write the process in PV to the power of your X. PV to the power of your X. PV to the power of X is equals to constant. How do you change? That is very important for me. We need to take, see, whenever the process is not in the form of P and V and the given process is TP, you need to use the ideal gas equation and try to convert it in the form of your PV. Am I clear? Are you able to follow me? The given process is PV to the power of X. But for me, the given process is what better? Given is T P square is equals to constant. I need to convert this in the form of PV to the power of X. So what you will do? Use PV is equals to nRT. So from this one I can write temperature because I need to eliminate the temperature because I already have pressure. So T is equals to I can write PV divided by N into R. Isn't it?
Yes, sir.
So now you substitute the value of your T in the given equation. So in the place of T, this will be equal to your PV divided by N into R into P square is equals to your constant. So P square into P will be equal to P cube into V divided by N into R is equals to constant. Am I clear? So now this
Yes.
will become for me P cube V is equals to, this is constant here N into R. So this will be again a big constant K, because constant N is a constant, R is a constant. So this total constant I am taking it as of your K. K is again what, some constant. Am I clear?
Yes,
Am I
sir.
clear? Now I need to write in PV to the power of X. So what I can do? I can take this one P power 3 V to the power of, but divided by your power of 1 by 3. Take the power of 1 by 3 is equals to constant. So this will come for me P V to the power of 1 by 3. P to the power of 1 by 3 is equals to constant. Is equals to constant. Now this is in the form of what? PV to the power of X is equals to constant beta. Am I clear? So therefore value of X will come out for me how much?
1/3.
X is equals to 1 by 3. Now when you know the value of X is equals to 1 by 3, now can you calculate the work done all that one? I'm not telling that one. You can try to give me the answers right now on your own. Once again beta, once again you see, the given question is the monoatomic gas, number of moles are 4, undergoes a process Tp square is equals to constant, and its temperature is varying from 200 Kelvin to 400 Kelvin. Is asking us to calculate work done, internal energy, heat, and molar specific heat for the given process. Okay. Now see, actually our equation is what beta? PV to the power of X is equals to constant. But given equation is right now for me what? Given equation is in the form of your T P square is equals to your constant. This is a given for me. Now use ideal gas equation for this one beta. Use PV is equals to NT. I need to eliminate the T. So T is equals to PV into PV divided by NR. So substitute the value of your T in this given equation. So this will be PV divided by NR into P square is equals to constant. P square into P is P cube into V divided by NR is equals to constant. N into R will go on the other side. So PV to the power of 3 is equals to constant N into R. This total is a big constant, that is equals to your R. Now I need in power of PV to the power of x. So now what I did is I took the power for total equation by 1 by 3. So this 1 by 3 into 1 by 3 will get cancelled. So it is PV to the power of 1 by 3 is equals to constant. Now compare this equation with your PV to the power of your x is equals to constant. So we are getting x value is equals to 1 by 3. Am I clear?
Yes, sir.
Yes,
Now
sir.
calculate the questions. You know the value of x, calculate the work done, internal energy, delta Q and the process. Formulas gurtunnaya for polytropic process. For polytropic process, work done formula will be equal to how much beta? W is equals to NR into delta T divided by, this is the formula we will be using. NR into delta T divided by 1 minus x. Chalo, work done ఎంత వస్తుంది చెప్పండి తొందరగా.
1200 hours.
How much?
1200 hours, sir.
Very good.
1200 hours.
Okay. Still,
Delta Q 1800 hours.
delta Q
1800 hours.
1800 R. Very good. Next.
Delta U 600 hours.
Okay. Delta U
600 hours.
delta Q.
Delta U, sir.
Delta U is 1200 R.
W is 1200 hours. Delta Q is 1800 hours. Delta U is 600 hours.
How beta? See you.
Sir, delta U 1200 hours.
Yes, sir. Delta U 1200 R.
So work done का formula
Delta
लिखो
Q
पहले.
2400.
Okay. Work done is equals to NR into delta T divided by 1 minus x. Number of moles are how much for me? 4 into R. Temperature difference is how much beta? From where to where temperature beta? Temperature is from your
400 to
400
200.
minus 200. It will be equal to 200. I am writing directly. Divided by 1 minus 1 by 3. 1 minus 1 by 3 is how much beta? This is 800 into R divided by 1 minus 1 by 3 is 2 by 3.
2
Clear?
by 3.
So this will be equal to how much for me? 1200 into R. Got it? Then internal energy. Internal energy is equals to what is the formula? F by 2 and R into delta T. Monatomic gas, number of degrees of freedom 3 divided by 2. Number of moles 4 into R. Temperature difference is 200. 2 ones are 2 twos are. This will be equal to how much for me? 6R into 200. That will be equal to 1200 into R. Clear? Then delta Q. Delta Q is equals to delta U plus work done. Delta U is how much for me? 1200 R plus 1200 R. So this will be equal to 2400 R. Clear? And fourth one, C of your given process will be equal to how much for me? F by 2 plus of your 1 by 1 minus x into R. This is your formula. Number of degrees of freedom 3 divided by 2 plus 1 divided by 1 minus 1 by 3 into R. That means this value will be equal to 3 by 2 plus 1 divided by, this value is how much for me beta? 2 by 3 into your R. That means this is 3 by 2 plus 3 by 2 into your R. So this value will be equal to how much for me? C of your process will be equal to 3R. Nachinda, am I clear?
Yes, sir.
Any doubt? Am I clear? So I hope you got an idea how to do such type of a process questions when processes are given for you. Funny. అర్థమవుతుందా? Am I going fast?
అర్థమైతుంది సార్.
అర్థం కాకపోతే please let me know beta. Stop me and try to let me know your doubts. Clear? Chalo. The next type of process is your adiabatic. Very, very important for your NEET examination. Adiabatic process. In adiabatic process, it is a sudden process. So in this one, delta Q will be equal to 0. Isn't it? Internal energy formula, delta U is equals to F by 2 NR into your delta T. Work done formula will be equal to W is equals to NR into delta T divided by 1 minus gamma. I already told you. And delta Q is equals to 0. And C for the process will also be equal to how much for me? 0. Am I clear?
Yes, sir.
Adiabatic process delta Q is 0. Internal energy is F by 2 NR into delta T. Work done is equals to NR into delta T divided by 1 minus gamma. And C of the process will be equal to 0. Am I clear?
Yes, sir.
Now we have some relations in this one. I hope you remembered it, but still I'm writing it out fastly. First one is PV to the power of your gamma is equals to your constant. Clear? Next one is P T to the power of your gamma divided by 1 minus of gamma is equals to constant. Relation between pressure and temperature. The next one is right now TV to the power of your gamma minus 1 is equals to your constant. So these are the three processes which you should remember for doing the numericals. Am I clear? PV to the power of gamma is equals to constant. PT to the power of gamma divided by 1 minus gamma is equals to constant. TV to the power of gamma minus 1 is equals to your constant. Am I clear? I'm having the derivations of this one, but I'm not checking with your derivation. So don't bother about the derivation at this stage. So directly you need to remember pressure and volume relation, PV to the power of gamma, pressure and temperature relation, PT to the power of gamma divided by 1 minus gamma is equals to constant. Temperature and volume relation, TV to the power of gamma minus 1 is equals to your constant. Am I clear?
Yes, sir.
Next one, again important. Slope of isothermal process and adiabatic process. Okay, we are talking about the slope for your isothermal process and adiabatic process. Do anyone remember it better? Anyone? What is an isothermal process? PV is equals to your constant is your isothermal process. Okay, differentiate this one. It is dP into your V plus P into your dV is equals to 0. So it is dP into your V is equals to minus of P into your dV. So dP divided by dV will be equal to minus of your P divided by V. dP by dV is nothing but what beta? Slope. So can I say that slope of your isothermal process is equals to minus of your P by V? Am I clear? Am I clear? So the graph for
Yes,
this
sir.
one is something like this. So here it is pressure and here it is right now volume. So the graph is rectangular hyperbola like this. If I take any point here right now, so for that point draw a straight line like this. If I take that straight line right now, so this will be the slope for you. So this slope will be equal to minus of P by V. Am I clear?
Yes, sir.
So for isothermal process, slope is equals to minus of your P by V. The derivation need not be remembered better. Directly you can remember the formula which I highlighted it. Okay. Next one for adiabatic process. What is an adiabatic process? PV to the power of gamma is equals to constant. Is it దీన్ని కూడా మనం again we differentiate it. So I'm writing directly the formula dP divided by your dV. dP divided by your dV is equals to minus of gamma into P divided by V. Very important. So can I say that slope of your adiabatic process, slope of adiabatic is equals to gamma times of your slope of isothermal, isn't it? Because minus of P by V is nothing but what beta? Slope of your isothermal process. Am I clear?
Yes.
Very important beta. Slope of your adiabatic is equals to gamma times of your slope of your isothermal. Okay, so what is the formula for this one? dP is equals to dP by dV is equals to minus of your gamma of T by V. Am I clear?
Yes, sir.
Okay, so this was something a small. So this was some of the basic formulas in your what do you call thermodynamics beta. And damn sure we'll be getting one or two questions in this one, but damn sure one question from this one. If it is a formula based, it will be like this, whatever formulas I have written. Okay, I'll send you this notes today. You try to revise this complete notes. In the tomorrow section from 7 to 8 or 7 to 8:30, we'll try to go for an exclusively problem section on your thermodynamics. Today you can start with some of the PYQs of thermodynamics. See how was the question in 2014, how was the question in 2013. Yes, Nagvi, सुग्रह बोलो बेटा, कुछ बोलना था? I am sending the notes beta. There is a WhatsApp group. In that group, I am commonly sending the notes for everyone. Okay. See, these are the short notes which I am writing. How to revise in the last moment. So thermodynamics, I almost all revised you in 1 hour. As I am writing, it is taking time. Now, for you to do the revision of thermodynamics, it will literally take you not more than 10 minutes. Okay. In 10 minutes, you need to completely revise it. Okay, you can revise the thermodynamics. And in the tomorrow session of a class, I can do the quality questions on this one. But before that, what do I request is go through the question in 2014. How was the question in thermodynamics? In 2013, how was the question in thermodynamics? Okay.
Okay, sir.
Today, you please at least try to do last 5 years questions from thermodynamics. So you'll get an idea, whatever the formulas we revised, whether it will be useful or not for me. Okay, then we can do some problems on the thermodynamics in the tomorrow session of a class. Tomorrow is Sunday, so Sunday the timings will be different. So I'll let you know the timings in the WhatsApp group. And tomorrow there will be a longer session for complete 2 hours or 3 hours.
Yes, sir. Am I audible?
Yes, sir.
Yes, sir.
Lochana, are you able to understand beta?
Yes, sir.
Anvita, Mayuri, Maria Gauser,
Yes, sir.
Today is first section beta. अगर आपको कुछ problem हो रहा है, you let me know.
Yes, sir.
If I'm going little bit faster, you can let me know so that I can go still little bit slow. Okay, thermodynamics is the easy and scoring chapter beta. That is the reason I started with thermodynamics. You please try to do today PYQs, or else I'll also do for you. That's not an issue. Tomorrow in the class, I'll try to do some standard questions of your thermodynamics, highly expected models.
Sir, how many chapters are done till now?
No, this is 7 to 8:30 is a new batch beta. This is only the thermodynamics. In this one, I'll do all the chapters again. I'll do units and dimensions. I'll do errors. I'll do your vernier caliper and screw gauge. I'll do gravitation, kinetic theory of gases, heat transfer, thermal expansion, gravitation, center of mass, all the scoring and small chapters I'll try to do. And second year, I'll do complete modern physics again, atoms, dual nature, photoelectric effect, nuclear physics, semiconductors and devices, logic gates, and current electricity. We get 2 to 3 questions in that one. And magnetic effects of your current, again we get 3 questions in that one. And alternating current, again a scoring. Small chapters where you can do. I'm not touching the big chapters where there is a possibility that even after doing you maybe forget. I'll try to do that. I'm trying to see that at least 25 questions can be attempted in the final examinations. So like that, I'm first preparing all the weightage questions in the first session and all the easy questions in the first section. If all the easy topics and scoring topics are completed, at least 15, 20 questions you can able to do. Then remaining 5 questions, we'll try to go from the other topics which are a little bit larger like electrostatics, wave motion, wave optics. Okay.
Okay, sir. Okay, sir.
If you are having anything from your side, you let me know better. Alvina, ऑनलाइन
Yes,
समझ
sir.
में आ रहा बेटा? दिक्कत हो रही?
हाँ सर, नहीं समझ आ रहा है सर.
फिर ये सेक्शन में पूरा फिर स्टार्टिंग से होता है बेटा अलवीना. इवनिंग
जी.
7 o'clock to 8:30 you can listen all the lectures again. Second time revision. I'm doing all the topics again. I'm not leaving any other topic. All the scoring topics I'll be doing here. 120 marks weightage topics I'll be doing better. And my target is at least by April 15th I need to do 20 questions out of 45.
Okay, sir.
And grand test also we need to start better. Maybe from 25th I'll be starting daily one grand test. And that is free for everyone. Even if you are having your friend circles, you please let them know. I'm not charging for that one anything, but I'm not going to teach anything in that one. It is only the daily grand test paper for all the students who have completed their coaching in the different coaching classes. Okay, that means from 25th I'm starting April 25th. I'm doing daily one grand test paper. So almost like 40 grand test papers of Neet of 45 marks weightage, 45 questions pattern as per the new pattern. Okay, now? You can just give a word to your friend circles. They can join that session free of class. But evening sessions or all of them are paid sections. And 7 to 8:30 batch students will be only in 7 to 8:30 batch, and 10:30 batch students will be again different. Okay. अनम समझ में आ रहा बेटा? Okay. Harita, are you able to follow? Harita, చదువుతున్నావా కేటీజీ అయిపోయిందా? Okay, चलो बेटा, I'm leaving. Bye.